For number 9 and 10, we're supposed to solve the system of equations by graphing. So that means find the solution by graphing. And the solution is this point of intersection. So it says be sure to name the point of intersection. Find m and b first by isolating y. Luckily for number 9, the y is isolated. And they're in slope-intercept form, which is good for us. Y equals mx plus b, where m is the slope, b is the y-intercept. So for this first equation, 2 is my slope, and 3 is my y-intercept, b. And for the second equation, whatever's in front of the x is your slope, which is -1/2 in this case, and the y-intercept is 7. So now we have to graph and see where these two intersect. That's going to be our solution. So this first equation, the intercept is at 3 on the y-axis, so put a dot at 3, and my slope is 2. So if we're doing rise over run, it's rise 2, run 1. Rise 2, run 1, rise 2, run 1. There's that line. And the other line has an intercept at 7. And my slope is -1/2. So I rise -1, run 2. Rise 1, -1, run 2. Down 1 over 2. So these lines don't intersect at a perfect point. They will on your test, so don't worry. But I would say that they're about 1.5 over 1.5 on the x, and then we have to go up about 6. Again, this won't happen on your test. There will be an exact point of intersection. Number 10, we need to actually isolate this y on our own, because we need to get it in slope-intercept form in order to graph it. And slope-intercept form has the y alone or isolated. So there's a 4 multiplied to it. I'm going to do the opposite. I'm going to divide 4 to every term. 4 divided by 4 is 1y. 4 divided by 4 is 1x. And 4 divided by 4 is 1. So now whatever's in front of the x, which is an invisible 1 here, that's our slope, m. And our y-intercept, whatever is added on after, is also 1. For the second equation, that already has the y isolated, so that's easy for us. The slope is whatever's in front of the x, so again, an invisible 1. And the y-intercept is whatever is added on afterwards, in this case, -2. So to graph these, we'll start with the first one. The y-intercept is at 1, so on the y-axis, I put a dot at 1. Then I use the slope 1, which for rise over run is 1 over 1. Rise 1, run 1. Rise 1, run 1, rise 1, run 1. There's that line. And the second line has an intercept at -2. And the slope, again, is 1. So we rise 1, run 1. Rise 1, run 1, rise 1, run 1, rise 1, run 1. If you remember from before, we talked about what happens when the slopes are the same. When they're the same, we get parallel lines. And these two lines are actually never going to intersect. So when it says, where do they intersect? That question ended up on the next page. Where do they intersect? Well, they don't. They'll have no solution because they are parallel.